this is Aryan from More Than Just a Game, and this is another chapter on our Unreal Engine 0 to Hero tutorial series. In this chapter, we will cover blueprinting basics, and we will not go into advanced blueprinting, we will just cover uh, the basic level of the blueprints and how you can use them, what info they contain, stuff like that. We will basically go through implementation of a simple feature in our game so you can learn this along the way. By the way, most of the codes I write here are not best practices for blueprinting. They are not optimized, but they give you a sense of how to write blueprint codes. So it's better you avoid writing codes like this in production projects, especially if you have a more complex environment or mechanic in your game. So yeah, that's it. And when we basically go along with the implementation of that each feature, I'll tell you what the best practices are, but I'll probably not do them in this video. But I will briefly mention what the best practices are. So first we have to go through some concepts before we begin our actual blueprinting. So first concept is classes. If you already are remotely familiar with any programming language, you probably know what a class is. But basically you can imagine a class as a template for an object. So let's say cars. Okay, cars have some attributes. They have some properties. You may hear these names, these terms with different words. You may know variable, you may know it as property, you may know it as attribute, but they are almost the same. So a car can have some properties assigned to it, like what color it is, how many doors it has, how many, I don't know, wheels it has, if it's automatic or manual. There are some properties like this, and it has some functions too. You may also have the term method instead of function, but the functionalities that a car can have is, I don't know, steering left, steering right, gas, brake, stuff like that. Uh, so yeah, there are some functionalities like this. And then you can create an instance of this car template that we have, and we have defined some attributes and functions inside of it, and customize it as you want and have a new car created. So the class itself is not a car, it's not a car object, but it's something you can create cars from. It's like uh, a roadmap for creating a car, but it's not a car itself. So this is what classes are. So let's see an example from the default template, third person template of Unreal Engine. So this is the character blueprints that we have in Unreal Engine by default. As you can see, this is, the parent class for this is called character. If you open this up, if you click on this, it would open up in Visual Studio and you can see it's C++ code. But yeah, this is basically the parent class. So it means that this third person character is an instance, an object created from the character class. Why? Because our character is obviously a character. And then as you can see, we can customize it as we want. In the character class by default, a character movement component is attached to the character, but assigning values to it, like I don't know, maximum walking speed, stuff like that, this is something we can customize individually for each object we create from this class. So like I said, as a template in the character class, the character movement component is attached to this character, but then customizing it relies on the developer and falls into the territory of basically the object that is created from this character, from this class. So what we are gonna do, the feature that we are gonna implement is punching. We are gonna have an enemy. We are gonna be having a punching animation. We are gonna assign punching to a specific button, and then we are gonna make that character, that enemy, take hits from our character. So let's begin. I'm gonna open up the character blueprint again and show you what a blueprint looks like. So first of all, we have event graph. This is where our events exist. Then we have functions. So this is a function basically, but this is a function of a character class. So when we have character class, when this is an object of a character class, we can basically use any function that exists in the character class, because this is a child of that character class. And character class itself, let me show you here. So yeah, as you can see, character class itself is a subclass, a child class of pawn, and pawn is a child class of actor, and actor is a child class of object. So what this means is that you can use any function that exists in character class, pawn class, actor class, and object class. So I think add velocity. Okay, no, that doesn't exist, but I think I can do this and this. Target as primitive component. No, this is not what we want. Okay, this must be, yeah. So as you can see, this is basically a function that exists in the actor class, but we can use it here because it exists in the actor class, and our third person character class is a child class of character. Character is a child class of pawn. Pawn is a child class of actor. Therefore, we can use any function that exists in actor class and is exposed for us to use, like this function, for example. But we can have functions specific to this class too. So let's say we are going to have a function, we are going to call it print something. This is the function that we are going to have, and inside it we are going to call print string. This is a generic function in Unreal Engine. It basically prints any text you give it to your screen. Let me show you an example. So on event begin play, I'm gonna call print something. Event begin play is something that's called whenever the actor is created or added to the scene. So as you can see, it says hello right here. This is our print something being called. But then we wanna basically make it more customized. What are we gonna do? We are gonna add two inputs to this function, so it's more scalable. We are gonna call this text to print. We are gonna call this duration to play to show. Okay, so text to print is a string. A string is basically a series of characters added together. So hello is HELLO. These are all individual characters, and then added together, more than one character basically added together would become a string. So we are just gonna hook this up to here, or we can just get text to print. And then we have duration to show. This should be a number. We can make it an integer. An integer is a whole number, but a float is more suitable because we may want to display it for 1.5 seconds. So we're gonna move this up to this place, duration to show, and then we can have default values for each of these. So for default value for this, I'm gonna say something. For default value of duration, I'm gonna say 10. And then, as you can see, the default values are basically shown each time we want to call print something. So by default, the default values exist, but I want to change them to something else. I'm gonna print again for 3 seconds. As you can see, it now says begin for 3 seconds and then it disappears. So this is how a function works in Unreal Engine. Then, as you can see, we have input variables. In a function, we can have output variables. So let's give you an example of a function with an output. So I'm gonna call this function a is bigger than b. We are gonna have two inputs. There are two numbers, one is a, one is b. I'm gonna say if a is bigger than b. Obviously this is a stupid function to have because in Unreal Engine we already have this built in, but I'm just gonna redo it, reinvent the wheel so I can just show you how a function output works. Okay, so the purpose of the function is to tell us whether a is bigger than b or not. So we are gonna compare these two. This rep is a boolean. A boolean is essentially either true or false. It would tell you if a value is correct or incorrect. So if the comparison of a and b, a larger than b, is true, it means that a is bigger than b. But if it's false, it means that b is greater than a. So we just want to return this value, this boolean value. So what are we going to do? We add this node called add return node. We are going to add an input, add an output to it, or we can just drag this and add this to this. And let's see, let's basically test it out. Okay, we're gonna do a bigger, and then we are gonna do 10 and 5, and just for the sake of visibility we are gonna print this for 5 seconds. Actually, let's instead use our custom print function. We are going to convert boolean to basically string, and then we are going to make it 5 seconds. Let's test it out. Okay, it says true. Why? Because 10 is greater than 5. So yeah, that's it. And then there's something you can do if your function does not actually change any of the public values of other classes or this class. You can make it a pure function. Let's check this. It looks like this right now. You don't have to connect the execution pin right now, and it just works like that. So let's test it again. It again says true. If I make this 15, it's gonna say false. So yeah, this is how pure functions work. And then about the execution pin I just mentioned, I'm gonna add a print. I'm gonna call our print something function here, but I'm not gonna connect the execution pin to this. Let's see, it doesn't print anything. Why? Because the execution pin is what defines the flow of actions. So this wouldn't even be called because it's not connected by any sort of execution pin. It has to be connected to some sort of event to work. So after we connect this, it does print something. So that's how the execution pins work in Unreal Engine. Then next thing we have variables. You can have global variables in your character class. I'm gonna call this let's say text to print again. I'm gonna call it, make it a string. Okay, actually we have the same name here. Let's change this. I'm gonna call this print text. Okay, and it kind of gets messed up. Text to print. Okay, make sure you don't have duplicate names like this. So we have print text here, and I'm gonna make you familiar with something else, with another event. It's called event tick. This event tick runs every frame of the game. So on every frame of the game, we are going to print the text, whatever we have assigned to this global variable. I'm gonna call it global text, and then I'm gonna use print something function. Hook this to there and make it, yeah, I'd leave it at 10 seconds. You can see every frame it says global text. So the purpose of this function, this variable being global, is that you can use it anywhere. You can use it in any of the functions that you have. So yeah, just like that, you have access to this everywhere. But for local variable, so let's make this text color a local variable. As you can see, you have an option called promote to local variable, and you have promote to variable. If you press promote to variable, it would make this a global variable. But I'm gonna tell you what a local variable is. I'm gonna call this print color. Okay, I'm gonna change this to red. Okay, that's enough red. Yeah. So we have a local variable called print color. Oh, so can I access it here? I can't. Why? Because it's a local variable. It's only recognized in this function because it's local to this function, and I can't access it outside of this function. But I can change it. I can change its default value in this function. I can set the value of that function to anything that I want. And yeah, that's it. But as a global variable, I can have access to it anywhere. And then for variables, we have a get and set access type. For getting basically means reading the current value of this basically variable. You can drag this and you can see we have get and set, but an easier way is to hold control button and then drag this, it would get. Hold alt and drag this, it would set this variable. Okay, so for get, this is what we have used so far. We have used get. I'm gonna set this at every frame. So I'm gonna do what? I'm gonna do a random float in range. I wanna have a random float value between 0 and 10, and I'm gonna convert this value to a string and then update the value of print text to this chosen float basically. So every frame except the first frame, because the first frame this hasn't been applied yet. The first frame it's gonna print global text, and for the next frames it's gonna have a random float, update the value of print text, and then print that text when the next frame comes. Let's see. Yeah, you can see the frames calling the random float thing and the value of that being updated. Okay, this is how setting a variable works. Okay, so next thing, we already did this IA input action print a few videos back. I'm gonna rename it to IA punch. For 2 years I would still go with pressed because I want this to be only run once when I press the punch button, and then I have assigned the button 0 on keyboard to punching. So what I'm gonna do is I'm gonna call the event IA punch, and I'm gonna use the started one because that's what we have assigned as a trigger. And then right after this I'm gonna implement my punching logic. So for the punching logic, as you can see, I have a punching animation. I have got this from an animation pack on Fab Marketplace. So we have this punching animation, but this punching animation is using another skeleton than the one that we are using. Let's see what a skeleton is using. The skeleton is this one, not edit but browse to asset. Okay, this is the skeleton that is using. It's a skeleton inside that animation pack, but we want to use our skeleton. We want to use basically this skeleton. So what are we gonna do? We are gonna navigate to that animation. We are gonna do replace a skeleton. This is because it is rigged with Unreal skeleton, so we can easily just replace the skeleton. Which one is it? Yeah, it's this one. Okay, it just crashed. Okay, I think the reason for the crash was that I was replacing the skeleton with an Unreal Engine 5 skeleton, but this animation is rigged for Unreal Engine 4 skeleton. But luckily we have inside the third person template, we also have a Unreal Engine 4 skeleton. So we are gonna replace the skeleton with this one instead and see if it would crash again. Yeah, no, not this. The animation. Replace, and you can see the directory. Yeah, this is the one that we want to use. Yeah, it worked this time. And as you can see, it's working perfectly. We are gonna do the same for the punch reaction animation. This is the punch reaction. I'm gonna replace the skeleton for this. But one thing I have to do now is that because I'm using the character with Unreal Engine 5 skeleton, I can't use that animation on this unless I do something called retargeting, as you can see here, but it's a more complicated process. Instead, I'm just going to change the default character of this map. So the default character for this map is defined right over here inside third person, and then in the character class. Yeah, as you can see on the mesh, we have assigned the skeleton that we want to use, the skeletal mesh. Actually, I'm going to press Ctrl space, and I'm going to change the skeleton right now, the skeletal mesh actually. Yeah, let's test it out. It's working fine. The animation kind of is not matching this mesh. It needs some adjustments, but for our purpose it's gonna do fine. Okay, so let's go back to what we were doing. So what we were doing was assigning the punching animation to our character. So when we press the button 0 on keyboard, it would play a punching animation. Let's see, like this. Okay, right over here you can see, no, not here, but here, not even here. Yeah, that's right over here. Okay, and you can find it here too. Is the animation blueprint that this character is using. Maybe it works better with this other animation blueprints now. It's got almost the same. Forget that. Okay, this is the animation blueprint that we are using right now. An animation blueprint is essentially what tells the character what animation to play at any occasion. So as you can see, we have some basically variables that are set up. So for example, by default is falling is set to false, but if I set it to true, it's gonna play the falling animation. And then these values, these variables are set somewhere else through the blueprint codes or C++ codes, if that's what you want to do. So as you can see in the event graph for the animation, we first access the character and check if the character exists or not, because if it doesn't exist and we want to do something to the character, it's gonna crash. So we check, this is basically the default code in Unreal Engine template. So we first check if the character actually exists or not, and then we have a sequence node. The sequence node basically is for sorting out your blueprint so it's not a mess. They could have just made it like this. After this, you could have made it like this without a sequence node, like this, but it kind of doesn't look good, so it's better to use sequence nodes for when you wanna basically run a few logics one by one. So first of all, we get access to movement components of the character and then access its velocity. Velocity is basically a vector, and a vector is a variable that contains 3 values. No, this is not what I wanted. Yeah, this is how it looks like. It has x, y, and z. So the velocity vector tells you what speed your character has in each axis of the map of the 3D environment. And then based on what velocity it has on the xy surface, it's gonna assign that value to ground speed. So yeah, it's gonna calculate the float value of your velocity vector in xy plane and then assign it to your ground value, ground speed. This is basically the speed your character has in this surface, okay? So any speed in the up and down direction or axis is not calculated in this, okay? So yeah, but I wanted to show you the is following implementation. So by default in movement component we have a is following function, and on each frame this event is run each frame. On each frame we are going to update the value of is following to whether the movement component is telling us the character is falling or not. Okay, and then you can find the references of each variable by pressing Alt, Shift, and F, or you can just do the find references like this. And then we can use where we can see where it's used. So yeah, these are the places that animation is used. But for the sake of simplicity, I'm gonna do something kind of more basic for playing the punch animation. Okay, so let's actually make a variable of type animation asset animation. Let's see if it's an animation montage or it's an animation sequence. Okay, we're gonna make it an animation sequence. Yeah, animation sequence object reference, and then we can change its default value. I'm gonna give the punch animation to the default value. Punch. Okay, and then we are gonna do what? Okay, before actually playing the animation, let's test if our basically input action works or not. We're just gonna print hello each time we press 0. Yeah, it's working. We are gonna delete that, and then we are gonna do play animation and okay, we are gonna do okay punch animation. All right, we're gonna play this punch animation each time the 0 is played. Yeah, and then something else we want to do is after this animation is done playing, we want to basically revert things back to the animation blueprint. So yeah, we have this punch animation and we want to see how long it takes to play this animation, so we get sequence length or get play length. Yeah, and then we are gonna do a delay node. This means that it's gonna wait this long before running this code, and after this we are gonna do what? We are gonna do basically we get access to the mesh again. We set animation mode to use animation blueprints, and then we set anim class. We set it to, let's see what it was called. Yeah, we set it to this. You can basically, instead of typing the name, you can just click it in your content browser and then click this arrow. It's easier this way sometimes. Let's see if it works now. Yeah, it does. There's one problem with this. It's that if I repeatedly press 0, it's gonna go like this. It's gonna go crazy. So I'm gonna do something. I'm gonna store the state of whether the character is punching or not as a global variable. I'm gonna say B is punching. That B is a naming convention for Boolean variables. So this variable is gonna show us whether the character is currently in a punching state or not. So we do a branch. We only want this punching logic to run if our character is not already punching. So if it's doing anything else, such as walking or anything, we wanna do the punching logic. Okay, so if the character is not punching, we are gonna basically run this code, and then as soon as it starts punching, we are gonna set is punching to true, so this doesn't run again if we press the punch button again. And then after the punching is done, after the delay, we are gonna set it to false. Let's see, I'm gonna spam the 0 button, but it's not gonna work unless the punching animation finishes. Okay, now we are gonna do something else. We are actually gonna implement some actual punching. What we are gonna do is add a add a sphere collision. Collision is basically a component you can add to your character or actor, and you can basically be notified when something hits this basically invisible area component hit, or something starts overlapping with this component. You have a lot of access to stuff like this. So we are gonna basically attach this. Yeah, we have attachment socket. Okay, let's actually open up our character skeleton. This is the skeleton that we are using, and then on the right hand, let's see if it was actually punching with the right hand. It's actually the left hand. Okay, so on the left hand, yeah, we can add it to this one. We are gonna add a socket. We are gonna call this punch, and then we are gonna attach this to punch. Okay, as you can see, it's not exactly on the left hand because of this. It's exactly on the left hand right now, but we want to make it smaller, so we are gonna make the scale uniform. We are gonna decrease it, or you can just change the radius. It's better to change the radius instead. Okay, we are gonna make it like 15, and then we are gonna give it a better name, punch collision. Yeah, okay. Let's actually make this. It's by default hidden in the game. We are gonna set hidden in game to false so we can see it in game. Okay, you can see this, and you can see it play out like this. Okay, and then on, let's see, we have on components begin overlap. We are gonna do something. What are we gonna do? We are gonna check what it has hit, what actor it has hit. So get display name, and we are gonna print the name of the actor that it has hit. So by default it prints the name of this character because it collides with itself. So there's no collision set on that mushroom. Let's see. Yeah, it keeps hitting our character actually for some reason. Yeah, we should basically tell it to stop. Ignore actually our own character. Let's do that. Okay, there's no need to actually ignore the character, but you have to set up this collision correctly. You can set it to trigger and make sure generate overlap events is set to true, and then right over here you can see we are printing the name of the character that's being hit basically. And then let's create a sample actor. We are gonna call it BP test actor. I'm gonna add a cube to this. I'm gonna make it larger, not that much larger. Let's disable snapping. Okay, I'm gonna drag and drop an instance in here and see that, check if it's working or not. Obviously it prints the name of our own character, but it also prints the name of test actor. If I have multiple of this, by the way, I'm duplicating this by holding Alt and then dragging outside this. If we have multiple, it's gonna say test actor 2, test actor 3. For this one, it's gonna say test actor. Okay, this is the name of them that exists in here. If I rename this to something, it's the middle one. I'm just gonna say something. Okay. And then what are we gonna do now? We are gonna create a basically enemy blueprint. So let's create a folder called blueprints, and let's create an instance of character class because an enemy is a character. Let's call this BP enemy. Open it up. We are gonna basically give it the same mesh as we did with this guy. So let's basically find this mesh, assign it to here, and then is -89, and yeah, we are gonna apply all of that settings so it faces the capsule's forward vector. As you can see, the arrow is right there. Then we want to assign the animation blueprint again. It's this one. It's not getting applied for some reason. Okay, let's type it out. Yeah, okay. It's now applied. Okay, let's actually do something about this. I'm gonna duplicate this. And then let's actually, okay, yeah, we are gonna do this right over here. We are gonna set this to 0, 0, 1. So the enemy's material is different. Oh, let's find this. Okay, the enemy's material is different, and we can kind of distinguish enemies and players because right now they are using the same skeleton. Okay, let's drag and drop this into the scene. It was under blueprints. Yeah, what am I doing? Okay, it's right here now. Okay, let's see if we punch this we can get its name printed. Yeah, it says BP enemy. And then okay, we are gonna do something right over in this character. After the punch is applied, instead of printing, we are gonna use casting. What is casting? Let's actually first write the code. Okay, casting means that we already know that this variable that begin overlap returns to us is of type actor, but casting lets us be more specific. I can cast this to character class because we know that character somehow is a child of actor class. It's not directly a child of actor class, but eventually it is. It's like a grandchild of actor class. And same thing exists with enemy class. With enemy class we have this pattern. Enemy is a character, character is a pawn, pawn is an actor. So an actor can be casted to an enemy, but not always it's true. Like when the punch collision hits something, it's not always a enemy class. So we're gonna check if it was an enemy class or not. If it wasn't, we're gonna print not enemy. If it was, we are gonna print the name of the enemy. So it says not enemy at first because it's hitting our own character, it's colliding with our own character. It says BP enemy, then not enemy again because it again collided with ourselves. Okay, next thing, now we can tell that this is an enemy that's being hit, then we are gonna have a function in BP enemy. It's gonna be called take hit. Actually, instead of making it a function, let's make it an event. We do add custom event take hit, and then we have a variable. It's gonna be total health. We are gonna give it a type of float with an initial value of 100. Take hit is gonna receive an input of type float. Damage. Then we are gonna reduce the damage from total health and set it back to health. If it's less or equal, actually, if it's less than or equal to 0, we are gonna die. I'm not gonna do the true node yet, but I'm gonna do the false node. This is basically when we take a hit but we don't die. So I'm gonna do something similar to what I did in that other actor, in our own actor. We are gonna play animation. This time we are gonna play the punch reaction animation, and then we get play. Sorry, no, let's actually promote this to a variable. We are gonna call it punch reaction animation. Excuse the typo. We are gonna make it a anim sequence. Okay. And then let's give it a default value of punch reaction animation. We are gonna get its play length. We are gonna do a delay based on the play length. And then after the delay is done, we are gonna revert. What did I just do? We are gonna revert things back to normal. So set animation mode to use animation blueprint. And then set anim class to many. Yep, this one. Okay. So yeah, okay. Actually, for the sake of checking things out, I'm gonna print the health after it's been reduced, and then right over here after casting, we're gonna say take hit. And then we are gonna do a random float in range of maybe between 2 and 10. So with each punch, our enemy takes between 2 and 10 damage. Okay, so there's a problem. So because our capsule, our sphere collision with a punch animation goes inside and outside of the character multiple times with just one hit, it applies the damage multiple times, but we don't want that to happen, so we apply something similar to this. We store the state of being punched. Let's make this a bit more organized. Alright. So we are gonna have a variable called b is taking hit. Sorry, is taking hit. We are gonna make it a boolean, and by default it's gonna be false. And as soon as we take a hit, we set this to true. Actually, no, let's do that after this. Yeah. So as soon as the take hit is called, we are gonna set is taking hit to true. And then actually before this, we are only gonna do this if we are not already taking a hit. So we set it to false, we hook it to the false. If it's not taking a hit, then start taking a hit, and after the animation is played and the delay is finished and all that, we are gonna set is taking hit back to false, so it can take another hit. Let's see how it plays out right now. Yeah, just like this. I'm gonna change the basically damage to maybe 50 to 60 so that it dies sooner with 2 punches basically. And you would see that it wouldn't play that animation anymore because it's already dead and it should just disappear. So what I'm gonna do, you can basically play a death animation at this point with the same logic that we did for taking a punch, but I'm gonna show you another basically thing that you can use. So after you play your punch animation, after playing your punch animation has finished like this by getting the play length, I'm just using a 1 second delay right here. You can basically remove this enemy from your scene so the corpse is not laying on the ground anymore. You can call the destroy actor and it will get rid of this actor from the scene. Let's try it out with 2 punches. After a second punch, yeah, it just disappears because it died basically. So yeah, that's how you can use blueprints. I just did some example code. This is again not the best practices for blueprinting. This is not efficient. This is not optimized for large scale games. Using this type of flow for coding would first of all cause your blueprint to be chaotic. It would be a mess. You would literally see some spaghetti in your blueprints after you are done because this is not optimized for visual scripting. And then it would not be ideal for memory management either, because one problem that exists is that when inside our character blueprint we cast to enemy, it would basically load the entire enemy class into memories, and that's not really efficient to do. And you can have multiple things that can take a hit. So for instance, your enemy could be holding a shield. So we are after the cast fails, we are going to cast to shield maybe. We don't have a shield class in this project, so it's not recognizing it. But we can do that. We can cast a shield, and then even if it's not a shield, it could be something entirely else. Maybe if we are punching a wall, we want the player to take a hit because they have punched the wall. So after the casting to shield fails, we are gonna cast to wall. And after a few castings, all the classes in your project are basically loaded into your memory, and that wouldn't be ideal for memory management. I'm just gonna give you a hint on what you have to do on occasions like this, but I'm not gonna explain it because it's more of an advanced topic. But for this usage, you can use basically something called an interface. You can add an interface to your class, so right over here in class settings, you can basically add a new interface to your class. There are some interfaces by default, but you can make your own. And interface essentially tells the code that this class does have an implementation for a specific functionality, but doesn't care about what the class is or what the functionality is. So you can make an interface called damageable. You can give it a function of take damage or take hit, and then you can basically implement that in interface in here, and then add its function implementation in your event graph. And then what you want to do here is check if it implements that a specific interface, and if it does, you can call that function here. Like, you can call take damage, take hits, let's say. If the function in our interface is called take hit, we can call take hit directly on the actor without casting to it. But you have to make sure that you check if it is implementing that interface or not. And yeah, that way you can avoid using castings and loading the class into your memory. And after calling take hit, it wouldn't care for what the implementation of take hit is in that other class. Is it a shield? And if it's a shield, you may want to knock back the enemy instead of actually damaging the enemy. That would be taken care of in the shield class, not here. It doesn't care about it. Your enemy might be a big guy and it might start dancing after it takes a hit. It doesn't care that it's being punched. You don't care. Your character, your enemy might be a weak enemy and it might instantly die with one punch. But this code right here in your character class doesn't care about any of that. It only calls the take hit on any class that has been hit, and it does implement this damageable interface. So yeah, that's a best practice you need to use, and if you want to do that, you can just do some self-study, but it's a bit of a more advanced topic, and we will probably cover that topic in a later tutorial series which is more advanced than this. So yeah, if you want to hear more about our tutorials, feel free to leave a comment, like our videos, and subscribe. Have fun!